Phasor is actually a technique we're going to learn to use to solve an RLC circuit or RLRC, but usually RLC because those are the ugly ones, when your source is a sine or a cosine function. If your source is not a sine or a cosine, this is not the method you want to use. And again, as I said before, the way the technique really works, we're going to take a problem in time domain, a circuit problem in time. We're going to convert that to complex. Then we're going to solve it in complex because it's much easier. And the last step, change it back to time domain. Convert to time. And again, the reason it is much, much easier when your source is a sine or cosine, when your source is sine / cosine, it is much easier to solve it in phasor. In phasor than in time domain. So that's really why we're doing the switching. And to switch from time to complex or phasor is not that difficult, and to switch back is not that difficult. You'll see that in a minute. So what happens when you have a resistor in time domain? So this is time domain, and I want to switch that to phasor or complex. What happens when you have a resistor of the value of R? When you switch it to phasor, that resistor stays the same value. But because we're dealing with complex value, instead of R, we call it Z. So Z really is equal to the R value. That doesn't change. So if the resistor is 5 ohms, we'll say now has an impedance of 5 ohms. Z is really the impedance. When you have an inductor with the value of L in time domain, when you switch it to phasor, that has a value called ZL equals J omega L. Omega is the frequency. What's omega? Omega equals 2 pi F. In the USA, we use a frequency of what? 60 hertz, right? So if you do the math, it's 2 pi times 60, and you end up with 377. So a lot of times when you look in our book, you see a sine wave, your source, a sine, like 120 cosine 377 t. You go, what's the 377? That's what that number is, 2 pi f. If you're in Europe, Europe uses what for frequency? 50. That would be 314, you know. And again, if you're using, actually, this is in rectangular mode, we use J. But if you use phasor, this is what? Remember, your axes here, I'm just trying to put everything on the same line. When we did complex numbers last class, we said this is the real portion, this is the imaginary. So since that's a J here, your vector is pointing upward. So if you want to change it to a phasor that has a value of WL, because the square root of that, when you square it's the same thing, and the angle is 90 degrees. You're in the positive J direction, going upward. And if you have a capacitor, C, the value of that capacitor when you go to phasor, it's 1 over J omega C. Remember, J is the square root of -1. If you multiply the top and the bottom by J, you end up with J over J squared. Well, J squared is -1. So a lot of times we write that negative J over omega C. And again, if you want to convert that to phasor, it is 1 over omega c, that's the value. And the negative j, what angle? You can see that plus 270 or negative 90 degrees. It's the same thing. Negative 90 or positive 270. And what about the source? So we know how to convert the resistor, we know how to convert the inductor, we know how to convert the capacitor. What about the source? How do we convert the source from time domain to phasor? If you have a source of 50 cosine Wt plus, I always run out of space. I'll move it. Let's say you have that source. Let's call it, instead of a number, let's just use a variable here. We'll call some maximum value, Vmax, because that's the voltage source, some maximum number cosine Wt. When you switch it to phasor now, this source will be still the same source, but the value in phasor, we write that Vm, notice, and angle phi. So if I have a source now, and I'll put this aside, if I have a voltage source of 20 cosine Wt, let's say plus 30 degrees. When I switch that to phasor, that'll be what? 20 angle what? 30 degrees. What about if your source is a sine function? What is the difference between a sine and a cosine? Shifted by how many degrees? 90 degrees, forward or backward. So if you have a source, let's say current source, instead of voltage, we'll just change it, over value, I sub m sine Wt. That's a sine. I don't know if you can see the I there. First, I can convert that to a cosine. Wt. And the question I'm asking, it's 90 degrees, but I'm not sure if it's positive or negative. I forgot. We'll pick an angle, like 30 degrees, right? Let's say 30 degrees. So if you make Wt 30 degrees here, all of Wt is 30 degrees. What's sine of 30? 0.5, right? Now, if Wt is 30, let's say it's sine, I'm thinking as a plus. If I make it a plus, what's 30 plus 90? 120, right? 120. Now remember, all students take calculus. Anyone knows what that means?
Where
the trig functions are positive, correct, yep. So the sine is positive, the cosine is positive, the tangent is positive. Here only the sine is positive. Student begins with S here. Cosine is negative. The tangent is negative. Here the tangent is positive, which means the sine is negative. Cosine is negative. Tangent is positive. And in this quadrant, what? Sine is positive. Cosine is positive. Oh, sine is negative, cosine is positive. Only the C, the cosine, is positive. That's a negative. And the tangent is negative. So if I let WT be 30, the sine in the first quadrant is positive. So if I make this addition here instead of subtraction, addition, what's 30 plus 190? 120, you're going to be in this quadrant. Is the cosine going to be positive or negative? You know it's not right then. But if I make it minus here, if it's 30 degrees, what's 30 minus 90? Negative 60 down here. Is the cosine positive or negative? Positive, it matches that one. So it is a subtraction of 90 degrees. So when you have a sine function, to change it to a phasor now, in phasor, what is that equal to? Well, before I get to phasor, this problem becomes cosine WT minus 90. So in phasor, this will be what? IM angle negative 90 degrees. Oh, current source it was, right? There wasn't a voltage. I used a current here. I forgot. I use a current source here.
So that's your V now?
That's in phasor, yep. That's the negative 90, correct. So if I have, for example, my source now, a number here, if I have a current source or a voltage source, doesn't really matter, 20 sine 377t plus 40 degrees. I need to convert that to a cosine. This will be 20 cosine 377t plus the 40. When you go from sine to cosine, you subtract 90 degrees. So when you do the math, this source becomes what? 20 cosine what? 377t minus the 50. And now let's change it to phasor. Here we go. We're going to switch that to a phasor. In phasor, we write that as what? 20 angle negative 50. You see what happened to the 377? If your source is cosine 377t, if you calculate the current going through every branch in that circuit, or the voltage, they're all going to have cosine 377. What we're trying to find out is the difference, that value there. So at the end, my answer is going to be, I'm going to bring that 377 back in, but it's going to be shifted by negative 50 degrees. So let me take an example, put all these pieces together, and see how that works. Let me take a basic function. I go to the end of the chapter, grab a problem there. Just straightforward, simple question for now. I can make one up, but too early for me to make things up. Okay, there we go. Some stupid numbers in this one, but that's okay. It's only an inductor. Let's even make it worse. Inductor, capacitor, everything. Let's put the entire, here we go. I have this problem. And I always regret when I draw the picture before I write the value. I always run out of space. 4 cosine 100t minus 100t minus 20, and I just realized I already drew it wrong. That's a current source. My eyes are bad. For those people watching me on YouTube, that's a current source. I can shrink it. I can't shrink it really. 4 cosine 100t minus 20. It's a current source in parallel with 5 ohm resistor in parallel with the capacitor of 1 millifarad. We have another resistor up there of 2, and we have an inductor here of 20 millihenry. And the question is, can we find I of t, the current going that direction? Without doing this, I know if I have a cosine of 100t, this current's going to have a cosine of 100t in it. It might be a sine, but it's a shift anyway. But it's going to be 100t in it. So this doesn't go away. So the standard form for an equation for the source is some maximum value. In this case will be I max cosine, the way we write them, Wt plus phi. Well, phi here happens to be what? Negative 20. So what is W here is equal to? When you compare these two equations? 100. So the first step we said we're going to take a circuit from time domain and convert that to phasor. So when I convert that to phasor, sometimes you see a squiggly line means that's an AC source. We know that that's an AC. So this will be 4 angle what? Negative 20, good. We said the resistor stays the same. The capacitor becomes what? Negative J, I'll just put it down here, over omega C. So that's negative J, what's omega? 100. And what is C? C is 1 milli, right? 1 milli, which is 0.001. So you do the math, that's negative 10 J. So this is negative 10 J, or 10 angle negative 9 if you want to go in phasor. The resistor stays the same. The inductor is what? J omega L. Omega is 100. L is 20 milli. What's that? 0.02? 20 over what? 20 over 1,000. Is that 2? I think 2J, right? Yep, that's a 2J. And I'm looking for that one. What's I? Except when we switch to phasor, we start using capital letters to indicate we are in phasor. I said before when I was doing circuits 1, I used to do a lot of capital letters. I said when we get to phasor, to indicate I'm in phasor, we use I actually. So this is really not I of t now. It's in phasor now. Can't be time domain. So we'll just use the letter I. You can do IW if you want to say I'm in phasor mode, but I is fine. And you treat these just like resistors. How are these two connected? So what do? You add them. When you add them, what's 2 plus 2J? 2 plus 2J. And this is I. How are these two connected? We treat them just like resistors in parallel, the product over the sum. So where's my calculator? I'm lucky because my calculator can mix and match. I'm going to multiply this together. What's 5 times the negative 10J? Negative 50J. I'll get my answer in polar probably. I don't know. I'm not sure what mode my calculator is in. 0, comma, negative 50 that's negative 50j, divided by the sum of them, which is what? 5 minus 10j. So if you do the math, this is 4 minus 2j. I'm in rectangular mode, actually. Notice the math straightforward, just what we did before. What can we use now here? Can we use current division? So I'm going to apply current division. The current I equals the source, which is what? 4 angle negative 20 times this one. If you're looking for that current, we use this one, 4 minus 2j, over the sum of them, so again, if you have one of those calculators, plug in the values, negative 20, now times 4 comma negative 2 divided by the real portion on the bottom, 6, and what happened to the j's? Gone, right? And let me switch my mode to actually rectangular, polar, not rectangular. I want to be in polar mode. And the answer is 2.98 angle negative 46.57 degrees. Here's my first step. I took it from time, convert to phasor, solve it in phasor, which is this answer. Now let's convert back to time domain. To time domain, now when you take it, you can say the current I as a function of time is going to be 2.98. The cosine is still going to be there. The 100 still going to be there. And the only difference, the phase shift, is going to be what? Minus 46.57 degrees. In one page, boom, done.
Can you just explain to me again how you added up that 5 ohm resistor and the negative 10J capacitor?
This one?
Yeah. Like
Product over the sum.
just product of the sum.
Yep, they're in parallel. Just like resistors, you treat them. So the product over the sum, this times this, over the sum of them. This times that's negative 50j. So if I go negative 50j on my calculator, here we go. 0 comma negative 50, that's the top, because this one has to put real imaginary, over the sum of them, which is 5 minus 10j, divided by 5 minus, 5 comma negative 10. And I switch my calculator, this I'm actually in polar mode. If I change it to rectangular, and I say, what's that number? And that's where the 4 minus 2j came from. Yes?
Earlier, when you were talking about going from sine to cosine, is it always going to be subtracting 90?
Not correct.
You were just trying to...
Yeah, I just trying to prove why it's minus instead of plus, because people know it's 90 degrees, but they're not sure if it's addition or subtractions.
Right.
And they forget. And I always say, just pick a number, any number, and plug it in, see what the value of the cosine, and if you put a plus 90 there, it's not going to work. It'll give you a negative value. But if you put the minus 90, you'll end up with the right value. I wanted to prove it's a minus, not a plus, because I know people know it's 90-degree shift, but they always get confused. I can't remember if it's plus, minus, or which one is it? All the techniques that we learn in circuits 1, meaning what? Nodal analysis, mesh analysis, superposition, source transformation. We can use all these techniques right here. We can apply them right here and finish the problem. So let me take another example. And maybe I'll make this a little bit bigger and more challenging. Ready for another one? Here's another one. Let me write the value first, because I'm always mad. 3 cosine (100t) plus 62 degrees. That's my source. It happens to be a current source. Going through an inductor of 10 millihenry. So I can, instead of 10 millihenry, I'll go 0.01 Henry. How is that? That's 10 millihenry. 2 ohm resistor. .2 millifarad. What's 2.2 milli? Is that 0.002, is it? Farad. And a 3 ohm resistor. Five ohm resistor. Should we stop? Oh, keep going. Why stop here? Let's put another capacitor here. 4.7 milli, 0.0047 farad. And you know what? Let's put another source. And I can't write the value there, so I'll go 2 cosine 80t. (80). 2 cosine 80t. No shift. Now, if I wasn't doing phasor, I gotta look at the problem as 2 separate problems, because I have to look at it because there's 100t and this is 80t. The only way to do it is what? Superposition, because the frequency is different. So I gotta look at this, kill that source, and find the result due to that. Then kill this source, find the answer due to that, and add them. You know from circuits 1, I wasn't a fan of superposition because you gotta do the problem twice or 3 times, it depends. So this one here, we're gonna try to use phasor. And let's say my goal is to find the voltage right here, the voltage across the capacitor. What's this voltage? That's what I'm looking for. So I'm going to convert everything to phasor. My source here, this will be 3 angle what?
62.
62, yes. The inductor, what's the value of the inductor? J omega L. Which omega are you going to use? You really can't. You have to do superposition. You got to find the answer to this source first, kill that one, then you got to kill this and find the answer. But which omega do you use? Do you use the 100 or the 80? You can't. You can't just, I'll go 90 between them. It doesn't work that way. So I do, in this case, have to use superposition. I got to do the problem twice. You might not have an option. In this case, I don't have an option. So here we go. I'm dealing with this source. So I'm dealing with only the 3 cosine 100t plus 62 is going to be on. Only that source. I'll find the answer V first. We'll call it V1. Then I'll come back, bring that source, and find V2 or V double prime and add the 2 of them. So I'm only going to look at that source. So this is J omega L. Remember, the inductor is J omega L. The capacitor is what? Negative J over omega C. So here's the first inductor. Omega is what, 100? 100 times 0.01 is what? 1J? Two, 3, negative J over omega C. What is 1 over 0.22, right? What's 1 divided by 0.22? 1 divided by 0.22. I got 4.55 maybe, with the minus. Negative J over that number. This is the 5. And let's see the value of that. Negative J over 1 over omega C, 100 once 1 over 0.477. I should have picked some numbers. Nicer, 0.47, not 77. 2.13. And what happens to that source? It's a current source. So how do you kill a current source? Open. So that's the voltage due to source 1. We'll call it V bar. And now I got to solve this. Here's the good news. These two in parallel. Product over the sum. These two in parallel. The product over the sum. These two in parallel. The product over the sum. Just like resistors. You need a calculator that does polar to rectangular quickly. What, the calculators? Yeah. Actually, if you have...
89s do that?
The 89 does it really well. 86 does. I don't know 89. I have the 89. I have the 80, I'm using the 86.
89 on Amazon. It's used, but I found
$60, yeah.
A little bit more, like 70.
Yeah. But I'm using the 86 here, which really I find it for phasor is excellent. But really for engineers, you need the 89 down the road.
So the 89 can't do it.
The 89 does it.
Yeah, 89.
Yeah. The 86 is easy. All the keys right there. See the polar? I mean that rectangular mode, polar mode. You just go hit this one, hit mode, you know.
Can you show it again? Like, we'll do it on the screen. Like,
With this one?
Yeah.
Well, if you have the 89 is different. I'll show you the 86.
I have an
Yeah.
83.
So this will be the product over the sum. That would be what? 2J, right?
Yeah.
1J times 2, 2J on the top divided by 2 plus 1J. So this one will give me, and I switch actually mine to give me the answer in polar. So here we go. This one, 2J, so I gotta go 0, comma 2. I gotta put the real and the imaginary. That's 2J divided by 2 plus 1J, 2, comma 1. Enter. Oh, I switched, I guess, back to rectangular. I lied, because I keep switching. 0.4, comma 0.8J. That's the real, that's the portion. So when you find the equivalent of this, and again, I don't use now inductor, I just make a box. 0.4 plus 0.8J. Product over the sum, negative whatever that number is, 14, 15 over the sum of them. So let's see, 3 times 0, comma, negative 4.55 divided by 3, comma, negative 4.55. Product over the sum. And I got some ugly numbers, but I can leave them. 2.01 roughly. Minus J 1.38. Then I can combine these guys into one. Product over the sum. Let's do a product over the sum. 5 times 0, comma negative 2.13, divided by the sum of them, 5 comma, negative 2.13. And I came up with 0.77 here, minus j 1.80. Now let's think back about circuits 1. If you have a current source in parallel with the resistor, can you do a source transformation? Yep, I can switch that, and I put the resistor up, and I can combine the two. So I can switch that source transformation here. This will be a voltage source, and the value of that is going to be this times this. This times this. So let's multiply them. 3 angle 62 times 0.4 plus, 0.4 comma, not plus, comma 0.8. This will be a source. Let me switch it to actually polar. I don't like this mode. And this will be 2.68 angle 125.4. I decided to switch to polar mode. On the top, this resistor will go on the top. You'll have this 0.4 plus j 0.8. Right next to it, you have what? 2.01 minus j 1.38. And right under that, you will have 0.77 minus j 1.80, and that's the first voltage V1 due to source 1. These two I can combine together, 2.41.
You do the source information?
Yep.
Would the voltage source then be AC?
Yeah, I just don't put this, I'm just lazy. Still cosine, I just don't put the squiggly line, any of them actually. 0.4 and 2, that's what? 2.41 minus j, what's that number? What's 1.38 minus 0.8? And that's 0.58. And this is 0.77 minus j 1.80. And now I can use voltage division. What's V1 says? The voltage division, it says the source 2.68 angle 125.4 times 0.77 minus j 1.80 over the sum of them. Let's add these guys. Well, when you add them, what's 2.41 plus 0.77? 3.18 minus j. Let's add these numbers. 1.80 plus 0.58. 2.38. And V1 will be what? 2.6, I gotta use brackets to write them. 2.68 angle 125.4 times 0.77 comma 1.80 divided by 3.18 comma negative 2.38. And my final answer for that is 1.32 angle almost negative 131 degrees. So if you want as a function of time, so V1 as a function of time is going to be 1.32 cosine, what was it, 100t here? Minus 131 degrees. That's what source 1 is going to do to you. Then we're going to go back and redo it with the second source and add them, and there's your answer with the two sources there. But there is no other way to do this problem. Unless you know trig and the two were to put together, the two sources. Sometimes if you have two cosine functions, you want to add them, you can play with trig identities and see what that answer is. Double the angle, half the angles, whatever it is. If I have time at the end of the class, I might show you how you can combine them if that was the case, you know. So let's see what source 2 does now. Repeat the problem again. The only problem is we can't use these numbers anymore. Why? Because W for the second one is no longer 100. What's W for the second one? 80. So I got to recalculate all of them. So don't make that mistake. Oh, I know what these numbers are. That's only when using that source and W is 100. For this, W is 80, and let me redo all these. So this source is gone. So now, let's look at source number 2. And when I said last time, we're going to repeat the whole class, I wasn't really kidding there. These techniques, they come back again. So we're going to look at only source 2 cosine 80t. That tells me for that W equals 80. So the first source is gone. This is the current source, that's gone. The inductor J omega L. Omega L, 80 times 0.01. Is that 0.8? 0.01 times 80. It's getting pathetic, I'm using a calculator for that. This is J.8. This is 2.
Did you want an open circuit?
Yes. This one, that's why I didn't put it there. So I just left it. You know, so I just didn't even draw that. That source is gone. If it was a voltage source, you make it a short circuit.
Oh, okay.
Yeah. Now this one, negative J over omega C. Omega is 80, C is 0.1, okay. 80 times 0.0022, and take 1 divided by that. What is 1 over that on this calculator? 1 over that number, I know somewhere here, 1 over x. I don't have to write the numbers. Where'd you go? 1 over x, 1 over x. I think x to the minus 1. Is it 5.68? Negative 5.68J. Double check that. I'm not really good with the calculator there. That resistor is 5. This resistor is going to be negative J over omega C. So 0.0047 times the 80, and take 1 over that. 2.66, so negative 2.66 J. And that source, the last source, is pointing down. I'll put the squiggly line so Omar doesn't remind me here. 2 angle 0. And I'm looking for this voltage. It's defined this way. So what's V double bar? That's due to the second source. So obviously it looks like it's going to be negative. That's okay. A negative, when you have a negative sign, that's nothing more than a phase shift of 180 degrees. And let's do the math. These two, product over the sum. These two, product over the sum. These two, product over the sum. Again, if you missed it, how'd you come up with these numbers? How'd you get this 0.8? The inductor is equal to j omega L, and the capacitor, it's negative j over omega C. That's how I came up with these numbers. So now the product over the sum, 2 times, that's 1.6j, 0 comma 1.6, divided by the sum of them, 2 comma 0.8. And this one is 0.74, so that's 0.743, angle what, 68.2? Product over the sum, 3 times 0 comma negative 5.68 divided by the sum of them, 3 comma negative 5.68. 2.65, 3, angle negative 27.8. Negative 27.8, not a plus. That's 27.8, just ran out of space there. And the product over the sum for the last one, 5 times 0 comma negative 2.66, 13.3 angle negative 90 divided by 5 comma negative 2.66. So this one's 2.348. 348, angle what? Negative 62. And again, V2 is right here, or V double prime. Now, can we add these guys? How are they connected? So you can add them, make one out of them. 0.743, angle 68.2, add to it. Oh,
Z, is there any reason you're calculating this side in polar instead of rectangular?
no, my calculum polar mode. It's easier. It doesn't really, my calculator doesn't care either way. So I just put them in any mode I'm in. And the reason I stayed with polar, because at the end I want to know what the angle is so I can convert that quickly, find what my value is in time domain, because you have to be in polar mode to go for the source now to find out what the value of the source in the phase shift. So that's the only reason why I put it in polar. I could have put it in rectangular. Plus 2.653, angle negative 27.8. As I said, when you have these calculators, it's really not that bad. When you have to do it by hand, then you want to be in certain modes. If you're adding, this is negative 11.8. .348, negative 62. Now I can find the current going up there. Notice I defined this voltage like this, plus on the top, minus on the bottom. But the current's coming down is going to split. I can tell you what that current. I. And if I know what that current, I can tell you what the voltage here is going to be. So how do we find what that current is? Current division. So what is I equal to? 2 angle 0 times that resistor 2.68 angle negative 11.8 over the sum of them 2.68 negative 11.8 plus 2.348 angle negative 62. I'm pushing a lot of buttons, so I said try these numbers, make sure I'm actually putting the right button. 177 angle 23.3. It's going upward. So what is V double prime then? It's going to be a negative. This one's going to mark it plus to minus, backward to this one. Ohm's law says what? V equals I times R. Ohm's law here says V equals what? I times Z. So it'll be negative I times Z. Negative because the direction, I is going to mark it plus to minus. I want that to be plus on the top, minus on the bottom. So it's negative 1.177 angled 23.3 times Z, which is what? 2.348 angle negative 62. When you take that number multiplied by a -1 or put a minus, the machine's going to take the minus, make a phase shift of 180 degrees here. So that number will stay the same, but you're going to see that add or subtract 180 degrees from it. Forgot to use brackets. 2.348 angle negative 62. And notice not a negative value because the machine does the phase shift for me. What'd you guys get for an answer? 2.76.
Do I have to convert to rectangular?
Let me try that because I think I might have hit some wrong key here. Negative 1.177. So I want to make sure I put the right one. Angle 23.3 times 2.348 angle negative 62. 2.762 angle 141.3 degrees. It was right here. So now what is V double prime as a function of time? Is going to be 2.762 cosine the 80t plus 141.3 degrees. So we found V due to source 1. We know what V due to source 2. If I put them together, what is V as a function of time? It is the sum of them. It's the sum of the two sources. The first one was 1.32 cosine 100t minus 131 degrees. And the second one, if you add to it this value, which is 2.762 cosine 80t plus 141.3 degrees. And that's what my final answer if I push all the right buttons. It's fun actually when I just wing it and I throw a problem there, go, oh, let's try this one. And you end up with really a good problem. That wasn't my intention with this one, but it turned out to be a very good problem. You get to see a lot of stuff in it. Source transformation, Thevenizing, superposition. What about mesh and null equations? We still can use them, but not today. Not much time left. Let's give you some homework to work on it, to practice.